equilibrium constant, you just have to make sure that in that expression you put in, the temperature that you put in is in Kelvin. Then it shows you a picture of the apparatus. It says the temperature of the catalyst bed was controlled to 723 plus or minus a half Kelvin. So is this isothermal or non-isothermal? It's an isothermal reaction, right? Okay. Pressure drop is negligible. And it says pure methanol was fed over the catalyst bed at such a low flow rate that decreasing the flow rate did not affect the measured conversion. That phrase is word for word in the manuscript. That's exactly how they describe their operating conditions. So what does that mean?
Is that equilibrium?
Right. So if you recognize that, you got 5 points. You didn't have to do anything else on the problem except recognize that if I'm slowing down the flow of a reaction and the conversion's not changing, I must be at equilibrium. If you thought incorrectly that the conversion would be 1, I think you still got half credit for that. Okay, so it says what was the conversion. It hasn't told you whether or not the reaction is elementary. It will tell you that in part 2, but you don't actually even need that at this stage. So how do we do that then? First, yeah, it is at equilibrium. And so we write down what is the equilibrium constant. The formula for the equilibrium constant was a hint that you might want to actually calculate the equilibrium constant. And this is what you get. Right? Any questions about that? That doesn't depend on the rate equations at all. That's sort of always true. Okay, so how do we then put that in terms of conversion? Well, that's our stoichiometry table. That's what we've been doing with it the whole class, right? It's putting concentrations in terms of conversion. And so you get A, B, C. What's the inlet of A? FA naught, right? The inlet of B is 0. The inlet of C is 0. It's a pure methanol feed. How much do these things change during the reaction? It's minus FA naught times X. 1/2 FA naught times X.
So you do have to multiply by 2.
Dividing by 2 is a bad way of describing what you do because it's going to mess you up when you derive the rate equation. The stoichiometry tables in Fogler, all of them have this as B over A times FA naught X. And they have another term here, which is theta B. So A is always 2. I haven't done anything to divide anything, right? A is 2. So this B is 1, A is 2, so you get 1/2. I think that's a clearer way of thinking about what you do. Now Fogler will often, though, write it as this. And unfortunately, I think it causes people to make mistakes in deriving rate equations, which is the next part we're going to get to. Yes?
Could you have equivalently said your equilibrium constant is the top one's raised to the half power over A for that equation? Each to the half power.
No, I mean that's going to give you the square root of the equilibrium constant. And then the number that you get for the equilibrium constant is not going to match. Right? If I take the square root of both sides, I'm going to get exactly what you described.
Not on the left
Wait,
side.
but I was taking the stoichiometric coefficients you have there, so that would make it the square root of KPI. I guess I'm not understanding.
The definition of the equilibrium constant is for the reaction as written. You can't divide by 2. The stoichiometric coefficients are by definition B, C, and little a. You can't change those stoichiometric coefficients. Otherwise, you would have gotten, let's say that the equilibrium constant was 4, you would have gotten 2. Right? So it changes the equilibrium conversion that you're going to get. Okay, so you substitute in, so if you want to put leaving the PFR, right, because that's what we care about, so you get FA naught times 1 minus x, and then both of these are 1/2 FA naught x. And so now I substitute that into this expression. Right? So what happens? The FA naughts all cancel. And you get x. At this point, you wouldn't have lost points for this, but you would want to put in x equilibrium, because this is only true at the equilibrium conversion. It's not true at any other equilibrium. And so then you get x equilibrium over 4 times 1 minus xe squared. And now you were told everything you need to find Kp. And so you could use the quadratic formula in order to find xe given Kp. And what you get is that first the ln of Kp was equal to 1.31. So Kp was equal to 3.69. And you got 5 points for solving for Kp. And then the equilibrium conversion was 0.794. Any questions there? So that part of this problem was worth 10 points. Okay, now this is one where a lot of people are going to get some points back. Now I went back and looked at it, and it's ambiguous. And I forgot to tell the grader, I didn't notice the ambiguity until some of you came up to me. So, part B says, derive an equation for the rate of methanol consumption as a function of feed concentration, yada, yada, yada. Finally, it's giving you what you didn't need it, again, for the first problem, which, again, might have been a hint. But it does now tell you, assume reaction 1 is elementary. Okay. So the rate of methanol consumption, first I'm going to put down what's in my solutions, and then I'll put down what's acceptable, and we can talk about why they're different. Okay? So within Fogler's notation, he would have called these two rate constants Ka and Ka-1. Maybe he would have put a positive 1 here. So those rate constants are defined with respect to a particular species. That's why the 2 isn't there. Again, you're going to get full credit for either of these. You will not get full credit if you only had one of these two 2's. So if you put the 1 here, but you forgot the 1 here, you know, that's wrong, right? Because every time this reaction goes in reverse, it makes 2 A's. So you have to have the 2 in both places. And as I mentioned earlier, you have to have this squared, and both of these should be to the first power. They shouldn't be half order or first order. Yeah?
Do we have to submit for a full regrade to get that, or just show you?
I think what I'll have you guys do, feel free to come by and bring it. And no, you don't have to submit for a full regrade, was the question. But to expedite things, I will accept you taking a picture of your exam and sending it to my email and CC the TA. Just that way, you guys don't all have to come by my office hours or be bugging me all week to get the... I think you would lose 2 points, I think is what I saw, at least on one person, they lost 2 points. So any questions about why both of these are valid depending on how you define the rate constants? I feel like this should bother you more than it does.
Which one is more correct?
Depends on what the rate constants are. So if I were to have given you like actual experimental rate data, this ambiguity would go away because the way that you define a rate constant would have had it baked in. You know, you would have had to make a choice. How am I going to define my rates and therefore my rate constants? And it would have worked itself out in the end. I see Fogler does this. I feel like he does this more often, where he leaves off a 2. Like I pulled one up today, and that's kind of why I did it when I went through it on my own. I pulled one up, and I can't remember the exact reaction, but I think it was like 2 NOs plus something. I don't know. It doesn't matter what it went to. And he wrote that the rate of NO was equal to K and then NO squared. So I feel like Fogler most often leaves that off. Yeah.
Okay, so why would you leave it off if 2 A's are being used?
So again, it depends on how you're defining K. And we did have this in our notes. But again, I realize the problem statement was ambiguous, so you're going to get full credit. But I think in the notes what we had was, you might remember that. So let's look at this problem. Again, this, in Fogler's notation, would have had A's, and this one wouldn't have. So let's forget that it's reversible because it's incidental to the point. So the rate is equal to Ka times A squared, and Ka is equal to 2